welcome to Lessons in Logic number 44. And the picture I've selected for the lower right-hand corner of the screen is another hiking picture from Taimo Shan, Hong Kong's tallest mountain. And here, I guess we're looking west. We're looking through a gap in some trees at some other area of New Territories, Hong Kong. And I want to say, I think Kadoorie Farms is over there. And actually, that's normally where they take the snakes. When a Chinese cobra slithers into someone's porch or something, the custom is for someone to capture the little jerk and release it at Kadoorie Farms. So I'm in Snake City over here, right next to Kadoorie Farms, and that's why I only hike in blue jeans unless it's winter or something. I don't want the little jerks chewing on my ankles. All right, let's do Reductio ad Absurdum. This would be Latin for a reduction to the absurd. A reductio ad absurdum proof is a proof that shows that something is false because it leads to something obviously false, which is a fancy way of saying a reductio ad absurdum is a fancy kind of modus tollens. If X, then Y, certainly not Y, therefore not X either, where Y is some kind of blatant contradiction. So a conditional proof temporarily makes an assumption to see what follows from it. A reductio proof is kind of like that. A reductio proof also assumes something, but it assumes something a bit different. It assumes that the conclusion of an argument is false, and then it shows how a contradiction would be guaranteed by that conclusion being false, which guarantees that the conclusion is actually true. So a conditional proof is something like this. You assume the antecedents to a conditional proposition. You find that the consequent follows from it. Then you say, if that antecedent, then that consequent. You assume something, show that something else follows from it. Then you say, therefore, if that thing, then the other thing. You're proving an if-then statement by assuming the if and then showing that the then follows from it, and then stating if that, then that by conditional proof. A reductio ad absurdum is different, and it has this pattern. You assume a certain thing is true. You show that some contradiction follows from it, namely that some statement is true and false at the same time. Which statement? Any dang statement you like. And once you have a contradiction in place, you can actually make any dang statement you like true and false at the same time. There are ways of doing this. If I remember, maybe I'll show you because that would be fun. Anyway, you assume something is true. And then you show that what follows from it is that some statement is true and false at the same time. Maybe the same statement, doesn't matter. Any statement is true and false at the same time. And then that allows you to conclude that what you assumed is true is not true. Now, with some double negation work, add a couple tildes here and there, 2 at a time, or subtract 2 at a time. You can think of it this way. You're assuming that the conclusion of your argument is false. You're having a tilde up there. And then your just a moment. I'm having trouble figuring out my Zoom controls here. You know, I think I got it. I don't know why it didn't work. Okay, there we go. There we go. You could think of it this way if you like. With a reductio ad absurdum proof, you're assuming that your conclusion is false. Then you show that some contradiction follows, and that allows you to conclude that your conclusion is actually true. So it doesn't really matter whether you have tildes here or not. But I think we'll stick with this custom. The reductio ad absurdum proof assumes a certain proposition is true, which leads to the conclusion that some contradiction follows, which allows us to conclude that that proposition is false. Now, that will usually, or at least often, require some work with double negation, add 2 tildes or take away 2 tildes to get to the final conclusion of the argument. So P in this pattern here is the negation of whatever it is you want to prove with the reductio proof, and Q is anything that follows under that assumption. I shouldn't even necessarily say, no, I should say anything that follows from that assumption. Okay, so now let's illustrate. This is going to be not that difficult. If it seems confusing, just watch the illustration, see how awesome and simple it is. Here's an argument. If A, then B. If A, then not B, therefore A. Now, this is a strange argument. Let's see. Just a moment. I see there's a typo here. As I suspected. There we go. It's actually not a very strange argument. Not at all. There's a very simple reductio proof. If A, then B. If A, then not B. Therefore, not A. That's better. Now it's not a strange proof at all. So you're trying to prove not A. So you assume A. And then you show by modus Tollens on lines 1 and 3. You assume A, and you show by modus Tollens on lines 1 and 3 that B follows. And then you do the same approach. You show by modus Tollens on lines 2 and 3 that not B follows. And then you take B and not B by I'm trying to remember the name of the rule. Conjunction. That seems right. You show by the conjunction rule on lines 4 and 5 that B and not B are both true at the same time. And that shows you that tilde A is correct. It shows you that A is not true. Therefore, tilde A by reductio ad absurdum proof on lines 3 and 6. By the way, I don't think I've used this term yet. Subproof is a great word that we often use for these assumptions, whether conditional proof or reductio ad absurdum. This whole box here, this whole indented area, this is a subproof. It's a subproof for the next line that comes after it. All right, so that's how that works. Now let me look at something. How would you prove this argument any way other than a reductio? Let me check. I think there might be ways of doing it, actually. Let's not go into it. But the point I wanted to make is reductio ad absurdum is a wonderful proofing strategy, and it will very often be very useful for completing a proof, especially if it's a proof you can't figure out how to complete any other way. I won't promise you that if you find some argument you can prove to be valid using a reductio proof that there's no other way to prove it valid, but it's a very good way. And it will work on any valid argument, I'm quite sure of that. Now, let me just show you, just because it's kind of fun, an alternative strategy for getting a different contradiction. Instead of B and tilde B, therefore B dot tilde B by conjunction on lines 4 and 5, you can use disjunctive syllogism and the addition rule. The addition rule allows you to take any proposition and then affirm that either it is true or something else. Since B is true within the scope of this assumption, it's true that either B or C, right? That's the addition rule applied to line 4. And that will tell you by disjunctive syllogism now on lines 5 and 6, 6 and 5 to state them in the correct order, that Z is true. But then you can use the same thing, the exact same pattern of reasoning here to get tilde Z. Like so. If B is true, then either B or not Z is true by addition on line 4. And since B is actually not true by disjunctive syllogism on line 8 here with line 5, B or tilde Z not B, therefore tilde Z follows. And that tells you Z is both true and false. And if you're thinking, that's crazy, that doesn't make any sense, well, you are correct. Of course it doesn't make any sense. We are dealing with a contradiction. I need to copy and paste a dot. I can't find my dot. So z dot tilde z by conjunction on lines 7 and 8, and therefore reductio ad absurdum on lines 10, sorry, lines 3 through 10 gives you tilde a, our assumption was false. So what do? We showed that you can make any darn contradiction you want. It can be something from inside the argument or not. It could be A, it could be B, it could be tilde A, it could be tilde B, it could be a horseshoe B, it could be a horseshoe tilde B, it could be X, Y, Z. It can be any proposition you like is both true and false. If that's fun for you, here's the way you can do it. But the initial point here, well, that was the initial point. The next point here is anything follows from a contradiction. If a contradiction is true, here's some logic you can use to show that anything follows from it. You can use these two propositions, B and tilde B, to show that anything is both true and false at the same time. And that's how you know contradictions aren't true. And that's how you know that the assumption that led to the contradiction is not true. A lot of this was just fun if you're the kind of nerd who can enjoy this. If you had any enjoyment of this, congratulations, you're a nerd. Keep it up. If you didn't enjoy this, it doesn't matter. You don't need to do it. You just need to be able to show some contradiction, any contradiction. In our earlier B dot tilde B contradiction was just fine, and you can just stop there. A contradiction follows from A, therefore A is not true. And this whole thing is sort of a glorified modus tollens. And that's pretty much it. Let's see what other examples come up and what other advice may come up in our notes. The Zoom controls are annoying me and getting in my way. All right, so we've illustrated a reductio ad absurdum proof. Now we're going to illustrate again. Here's another argument. If A, then B. If B, then C. If C, then D. And A, therefore D. Now you can do this easily with a, let's see, a disjunctive syllogism. No, not a disjunctive syllogism. A hypothetical syllogism and another hypothetical syllogism and a modus ponens, or modus ponens, modus ponens, modus ponens. But we're going to do it by reductio. And this is not properly formatted. Let's see. Ugh, my formatting is a disaster. I better pause the recording while I sort out my format. There we go. If A, then B. If B, then C. If C, then D. A, therefore D. And we're going to prove this by reductio ad absurdum, which means we're going to assume that our conclusion is false. We're assuming that the premises can be true and the conclusion false. At the same time, we're going to show that that leads to disaster, because a contradiction is a disaster. Okay, so you might easily see where this is going. You can work forwards or backwards here. You could go from A by modus ponens and stuff up through D, and then say D is both true and false. Or you can take the denial of D, here with this assumption, you can work backwards by modus tollens and stuff back to A being false. Either way will work. I'm going to do, and you can use hypothetical syllogism in here if you like. Let's do modus tollens. I want to do modus tollens. By modus tollens on lines 3 and 5, if C, then D, not D, therefore C, we get C. Not C. By modus tollens on lines 3 and 5, if C, then D, not D, we get not C. And then by modus tollens on uh, 2 and 6, I'm thinking, we should get not B. So 2 is if B, then C. 6 is not C. Our conclusion tilde B, not B, follows from that, and that's modus tollens on lines 2 and 6. Good. Everything's working out very nicely. So now lines 1 and 7 are if A, then B. Therefore, sorry, lines 1 and 7 are if A, then B. not B. And what does that tell us? It tells us not A either. Modus Tollens on lines 1, 7. And now, are we ready for a contradiction? Yes, we are. Now we go directly to the contradiction. The contradiction is going to be A and not A by, do you know which rule? Do you know which rule? One of our first rules, if I remember correctly. Conjunction on lines 4 and 9. 4 tells us A is true. 9, sorry, make that 8. A step should never cite itself. Conjunction on lines 4 and 8. 4 tells us A is true. 8 tells us tilde A. A is not true. So 9 can tell us A and tilde A, which is a contradiction. Therefore, the assumption that D is false leads to disaster. Therefore, D is true, which it turns out is line 10. And so lines 5 through 9 are reductio ad absurdum subproof that gives us our conclusion. That's it. That's how reductio ad absurdum works. All right, let's observe this. Abbreviated truth tables are actually reductio ad absurdum proofs on a truth table. They are a temporary assumption that the conclusion can be false and the premise is true at the same time. And then we follow through on some of the implications until we find that this leads to the disaster of a contradiction. And that tells us that the conclusion is actually true, given the premises. More precisely, that it's not possible for the premises to be true and the conclusion false at the same time, or again, more precisely, that the argument is valid. The premises do guarantee the conclusion. All right, let's review some stuff, and then maybe we're done with proofs. Unless we have one video left. I think we're done with proofs except one video. I want to go back to that Socrates argument and do a proof on it, which might be absurdly simple. We'll see. Proofs in a nutshell. A proof is a series of steps showing that the conclusion to an argument is guaranteed by its premises. Each step of a proof makes an inference from a step or steps that come before and justifies that inference by appealing to some infallible rule listing the step or the steps from which the inference was made. The step or steps from which the inference is made must have the same form as the statements in the rule by which the inference is made. In other words, the pattern of the rule, actually, since the rule is a pattern, I should just say the pattern which is the rule should be found in your move from the steps you're citing to the statement you're getting from those steps. And this is all because validity is about form, not content. Meaning it's about the things, it's about the pattern of reasoning, not the things we're reasoning about. Once an inference is made, it can be used to make further inferences. Now, everything I've just said here, typed up here, is perfectly reasonable and useful, or at least plenty reasonable and useful. But I should also say one more time, lest there be any avoidable confusion here. The assumption step of a reductio subproof and the assumption step of a conditional proof are an exception to this rule. These steps are not an inference from a step or steps that come before. They're temporary assumptions. They're allowing you to make some other inferences, and hence anything within the scope of that assumption, which we like to indicate by putting some lines around it or tabbing it over, indenting it extra. Anything within the scope of the assumptions does not necessarily follow from the premises. It follows from the premises plus this assumption. But if we use the rules properly, we'll use these things that follow properly to show in the case of a reductio that that assumption was false, or the case of a conditional proof that if that assumption is true, then something follows from it. Now, here are some rookie mistakes to avoid, or common pitfalls. I like this phrase. Rookie mistakes to avoid. Don't cite the wrong number of steps. Don't cite steps out of order. Don't have any steps citing themselves. Don't skip steps. Some strategies for constructing good proofs. Rules of thumb for constructing proofs, not a complete list. Well, the first point of strategy is to use a good strategy. Don't just look for things you can do first. Usually, the most helpful strategy involves working backwards. Look at your conclusion. See if you can find the conclusion or parts of the conclusion in the premises and see how you could get to them from other information elsewhere in the premises. If you get stuck, Here's a very useful rule that I probably have not had the sense to say explicitly here at all yet. If you get stuck looking for an atomic statement, will often get the ball rolling. A premise that's an atomic statement all by itself. When your premises are complicated, sometimes you can break them down using inference rules. For example, if you have a premise that says D dot Q, D and Q, you can break it down using the, what do we call it, simplification rule, to have an atomic statement D and an atomic statement Q. And then frequently, one of those will be an atomic statement that will get the ball rolling again. Consider logically equivalent forms of the conclusion. If the conclusion is a wedge statement, you can always convert that to an arrow. If it's an arrow statement, you can always convert that to a wedge using the, I believe it's the material implication rule. If the conclusion is a conditional statement, you can frequently get to it using a conditional proof, where you assume the antecedent of that conditional and show that the consequent falls within the scope of the conditional subproof. If nothing else works, try reductio ad absurdum. That's it. That's all I got on proofs. Golly, thanks for watching. I'm actually excited because although I like this stuff, I've been wanting for I don't know how many weeks to get to inductive logic. So I'm happy that we're just about done with all the deductive logic stuff. We still need 2 videos, though, to wrap it up, because I want to do, I think it's 2. I'll have to check my notes, but we still need at least 2. I want to do that Socrates argument and do a proof on it. I want to look at that argument one more time. And then I think we have a video summarizing statement logic, which should be useful. Anyway, thanks for watching. See you next time.